So we've covered GPON, XGS PON, 25 gig PON, 50 gig PON, touched a little bit on 100 gig. And if you hadn't had enough of PONs already, I'm going to ask Kevin to come on and talk about Coherent PON and how CableLabs are driving that. So over to you, Kevin.
Thanks, Greg. And it's good to see a lot of familiar faces in the audience. So thanks for coming and hearing what we have to say. Just briefly, who's CableLabs? We're most well known for the DOCSIS specifications. We developed the original DOCSIS 1.0 specs back in the 90s, and now we're up to 4.0. We connect over 500 million subscribers around the world with that. But we do a lot more than just DOCSIS. We are a nonprofit, member-driven research and development organization, and we have research in AI, wireline, advanced optics, as well as wireless wireline convergence, security and privacy, also in policy and market. So we do a whole lot more than just DOCSIS. As we look at where we have been so far, I look at this chart, I think about my career. I started my career in the early 90s when the commercial internet was just getting started. I think my first connection was 1200 baud, was advanced, or a newbie at that point. People had started much younger than that. But our careers, a lot of us in the room, certainly those of us on the stage, have experienced and contributed to that evolution from then until now, where we're talking about delivering multiple tens of gigabits to a residence. And that's pretty awesome to think about. But this chart is more than just a timeline. It is a representation of how the internet, how data communications has matured itself. And it's gone from what we call the speed era. So, the last 30 years or so, we've talked about speed, and we've measured the advancement of the internet and connectivity by how fast the speed is to someone's home or to a business. That's changing. It's changing significantly over the past few years, especially. I think COVID we use that as a good boundary of when to measure these things. And I think that's a good place where we started to realize that it's not just about speed. It's about reliability. It's about consistency. It's about the experience. So we call that the experience era. Moving forward, it's going to be more than that, right? We look at the experience era as what the user experiences, and I use the example of my mother or someone's 2-year-old child, my granddaughter, for example. They know how to install an app, right? Click, click, click. It just works, even if you're on Android. I got some giggles out of that. All right.
It took me a second, yeah.
It just works, right? They don't have to think about it. And that's the way connectivity should be. But it's not just for the user. It needs to be that way for the operator, right? So on the back end of this, as an operator is trying to deliver this seamless, consistent, reliable experience, they shouldn't be having to jump through hoops to make that happen, right? It shouldn't be a daily struggle for them to do that. And so that's where we talk about the adaptive era, where the network is adapting itself to the day-to-day and minute-to-minute changes of demand and outages and whatever may be happening in the network. And so today, we really one of the aspects that we're going to talk about or bring into focus is what we consider the unconstrained network, or the unconstrained network capability. And we talk about that in terms of this next generation of PON. Frank and Andreas have given a great introduction to where we are today and some of the market impacts or what's the word I'm looking for? The market, period, whatever. Anyway, so why are we looking at next generation PON? It's because we want to move into this adaptive era. The next generation PON needs to have more capacity, more scalability, and not just in speed, right? Scalability is more than just speed. It needs to be able to fit more subscribers on a single piece of fiber, on a single PON port. And that's important because we want to reduce the amount of space that's being used up in a central office, reduce the number of devices that happen to be deployed in the field. And that speaks to sustainability. lower energy costs. The next generation PON needs to be able to reach further out. A big focus for the Fiber Broadband Association is rural access. And so being able to reach further into those rural areas with less cost and fewer devices is important. And of course, then the improved experience is very important. We at CableLabs, we think coherent optics is the way to do that. Let me get through the build here. Oh, there we go. We think coherent optics is the way to do that. Coherent has been deployed for many years now. It's very mature in the backbone and even in the regional networks. And just like many other technologies that we've seen over the years, the cost and the scalability of that technology moves to a point where it can filter down into the lower, high-scale parts of the network where cost is a big deal, right? We're very sensitive to cost in that area. So we think coherent is a place for this. First, because it's much higher spectral efficiency. You've got 4 degrees of freedom to work with to move data to the endpoint. And it has generational coexistence with other technologies that are already on the fiber. So coherent can fit in with all the existing PON technologies as well as point-to-point type technologies. It's also more power efficient. With IMDD or intensity modulation, there's a DC carrier, so you're always spending some energy on sending nothing, really. There's no data in a DC carrier. So there's some power savings involved. So lowering the watts per bit. We believe coherent optics has an architectural advantage in that because we now have, it enables a longer reach, we have the ability to change the way we look at the network. Again, fewer devices out in the field, more focused, more centralized. And operational efficiency. We've already gone from pure IMDD to adding a DSP to achieve higher data rates. That DSP is there. We know that's going to happen. It's going to continue. Coherent just builds on that. And so with that smart processing that's in the OLT and in the ONU, you can now get metrics out of that to make the network even more operationally efficient. So where's CableLabs with what we call CPON or coherent PON? It is very much like a traditional PON. It still is passive on the ODN. It is still a point-to-multipoint topology. It still uses time division duplex with an upstream burst. We have aligned our work with the ITU, so the TC layer is based on 9804.2. But it's different. It uses coherent modulation, of course. It is a significantly improved link budget, 35 dB, which enables 80 kilometers reach, up to 80 kilometers, or to a 512-way split. We are operating or designing for 100 gigabits of operation, usable capacity, not to Andreas's point, where 10 gig PON really is 8-ish gig. So we have 100 gigabits deliverable to a service. And it's scalable, right? So we can either add more wavelengths or we could actually change the modulation complexity and go up to add more band or more capacity. We also remove the in-band discovery so that now we have more consistent latency numbers. The jitter is significantly reduced. We operate entirely in the C-band, so that's where we get our coexistence. We can support multiple wavelengths. The standard today supports 4 major blocks of wavelengths within the 100 gigahertz ITU grid, and tunable within each one of those blocks. And of course, that, again, is the coexistence story. As we entered into the project, we did take real-world networks and we redesigned them with coherent PON architecture involved or in place. And we found that there were savings and advantages in this topology versus traditional PON. So with the long reach, again, we can reach out into rural areas, low-density areas. In the urban and suburban areas, we can get way more customers onto a single port, again, reducing the cost of the central office and the power draw. All right, one more. There we go. Oops, come on. There we go. And again, coexistence. We are able to, with CPON in the architecture, to coexist with point-to-point optics on the same ODN as the other PONs. So GPON, XGS PON, Coherent PON, all can fit together. That would include 25 and 50 gig PON would coexist as well, which we didn't put on the slide, of course. I'm not sure why we didn't put it on the slide. I'll have to fix that. There's nothing against 25 and 50 here, but it just didn't end up here. Okay, a little bit against them. But.
Yeah, let's argue.
So anyway, so as far as the standard or the specifications, we have a CPON working group, very active for the past 3 years working on this. Engineers from CableLabs, from our member operators, and from manufacturers around the world. We have 4 CPON specifications that are published or in development. So we have an architecture specification that was published, I think, about a year ago now. The PMD layer specification, the first draft was published under NDA 2 months ago, I believe. The TC layer also, and then we're working on a modular interface specification. The target is to have all those in a publicly released suite of specifications by the end of this year. So kind of summarizing, we think that a coherent PON, CPON, enables an unconstrained network. And I could talk through the capacity impacts and the speed impacts of that, but we've already kind of hit those. But CPON breaks through those barriers of longer reach, higher splits, increased capacity, and the jitter and latency issues. And again, as I said, the specs will be issued by the end of this year, and we believe that by 2027 we would be seeing trials, and deployments would be dependent upon decisions by different operators, but we could have the technology available pretty quickly here. Thank you.
Okay. Lovely. Thank you, Kevin.